All right, so let's try another example here. In this case, I want you to just notice something about what our givens and our unknowns are for solving this full triangle, okay? In the previous example, we were given a side and we were given an angle. And that kind of forced us into a situation where we had to use trig functions to find another side. In this case, we're given two sides, all right? And so we don't have any angles. And that kind of opens things up a little bit because now we do have two of the three sides. We can use the Pythagorean theorem to start, all right? So A is our unknown. Oops, sorry. C is 13 here. That's our hypotenuse. And B is 7. Let's not forget where these angles are. Remember, they're named by the opposite side. So over here, this is side A. This is angle A. Over here, this is side B. This is angle B up here. All right? So these are both unknown in this case. All right? And so I'm going to start with Pythagorean theorem because I think that's the nicest one to use for this. All right? So A squared plus B squared equals C squared. All right? My A value is my unknown, so I'm going to write A squared. All right? My B value here is 7. That's going to be squared. My C value is 13. That's going to be squared. All right, so I'm going to go through and I'm going to square my 7. I'm going to square my 13. And then I'm going to subtract, which 7 squared we know is 49. We're going to subtract the 49 from the 13 squared, which is 169. Leaves us with 120. All right. And so 120, then we root both sides here to get rid of the squared on the A, and that's going to be 10.95. All right. So we've done pretty well here. We've already found one of our sides using the Pythagorean theorem. So see how this one is different because we have two sides. We can use the Pythagorean theorem immediately and get the third side. Well, now we need to attack and we need to get angle B and angle A. All right, and the only relationships that we have between sides and angles are sine, cosine, and tangent. All right. Now, since I have all three sides, I have a million different options here. I can solve for either angle B or angle A right now. Doesn't matter. I just need to pick the right function, but I have to start with some angle. So at this point, you're saying, well, which one do I pick? Do I pick A? Do I pick B? Do I pick sine? Do I pick cosine? Do I pick tangent? Don't pick the function first. Pick what angle you want to solve for. That's your unknown. All right. In this case, I'm going to go with angle A to start. All right. And so angle A is my unknown, and that means I need two more knowns, and I need two sides basically if I want to solve for this angle. So I'm going to go with side B and side C. And the reason I'm choosing those is because they were given at the very beginning, so I know that they're correct. All right. So what I do now is I look at angle A and I say, all right, side B, is it opposite or adjacent to angle A? Well, side B is adjacent to angle A. So I have an adjacent side. Side C is always the hypotenuse, so I have the hypotenuse. So I'm going to use cosine to solve for angle A. All right. So it's going to be the opposite, or sorry, the adjacent over the hypotenuse. Okay. And so the angle I'm looking for is angle A here. All right. The adjacent side is 7. That's my side B. And my hypotenuse is 13. Now remember here, A is being trapped by cosine, so we need to untrap it by ripping cosine away. And the only way you can take cosine away is with inverse cosine. So that's the reverse of cosine. It undoes cosine. All right. So I'm going to take the inverse cosine of the left side, and I'm going to take the inverse cosine of the right side. Anything you do to the left side, you have to do to the right side. All right. So what do cosine and inverse cosine do? They basically cancel each other out. They just get rid of each other. So whatever cosine does, inverse cosine undoes it, and that means we get angle A out of that cosine that it was trapped in. All right, and we're left with the inverse cosine of 7 over 13 on the right side, and that should be our answer. So all we have to do is pump that into the calculator. All right. Inverse cosine of 7 divided by 13, and we get 57.42. All right. Inverse cosine of 7 over 13 is 57.42. Now this is an angle, so this is degrees. All right. And so there we have our degrees. Now we could subtract like we did before, and that's probably the quickest way. The other way that we could do this, we could solve for angle B up here if we wanted to. So we could solve for angle B by using opposite and hypotenuse. So we could use sine and do the inverse sine. I think it's just easier to subtract at this point. So we're going to go with that. So I know that angle A plus angle B is equal to 90 degrees. And so I'm going to substitute my value for angle A, which we know is 57.42 degrees. Angle B is my unknown. 90 degrees is over here. All right. And I'm going to take my 90 and I'm going to subtract my 57.42, and that gives me a measure of 32.58 degrees for angle B. All right. Now, just to check yourself, look at these two angles. They should add up to 90 degrees, and they do. 32.58 plus 57.42 does give us 90 degrees. And so there it is. So this is another solution. We see this one is a little bit different. We ended up using the Pythagorean theorem in this one. We also had to use inverse cosine to get the angle because we weren't given any angles to begin with. So once we had that, we could use a little bit of subtraction and solve for the remaining stuff. So there you go. Example number 2.